So members, today we are looking at industrial preparation of acids, that is chemistry, industrial preparation of acids. So we are going to begin by looking at preparation of nitric acid. Nitric acid is one of the acids which is very, very crucial, and the formula of nitric acid is like that. Nitric acid can be prepared in the laboratory, but we have to look at it, how you can prepare it in the in the industry. So preparation of nitric acid is going to begin with about process. So can talk about process. About process, what are we looking for? The raw material, that is getting the nitrogen plus hydrogen to form what we call ammonia. So our ammonia gas here, ammonia gas from nitrogen and hydrogen. So we can balance our equation by putting a 2 here and a 3 there. After getting our ammonia, then what do? We get our ammonia, then we react it with oxygen. We oxidize the ammonia in simple terms. Oxidize our ammonia. This one is always done in the presence of a catalyst known as platinum, and this one is always done at a high temperature. So we have high temperature here. Remember, even here the condition is in double process. The condition is double process. Here we have to be with the high pressure, don't forget that. High pressure. Then we have to be with the moderate temperature. They always ask you those conditions. Moderate temperature. And then we have to be with the catalyst, or finally divided iron catalyst. Don't forget that for our process now. Then when you come here, we combine our ammonia plus oxygen. Then we get here what we call nitrogen monoxide plus some water. Our nitrogen monoxide plus some water. So after obtaining our nitrogen monoxide, we will have to balance our equation, saying the temperature must be high. So we can try to balance our equation there. You can balance by putting a 4 there. Then you can put a 4 there. Then you can put a 6 here to balance the equation properly. Now, when you look at that one, oxygen is not balanced, so we can put a 5 there to balance our oxygen. Now, after getting our nitrogen monoxide, members, we further oxidize nitrogen monoxide, so we add there more oxygen. Don't forget that. That is oxidation. Then the essence of that is to obtain what we call nitrogen dioxide gas. Even that one, we have to make sure the equation is balanced properly. So we oxidize it in presence of platinum at high temperature, as you are seeing. Then afterwards, we obtain our nitrogen monoxide. After obtaining our nitrogen monoxide, then the nitrogen monoxide, we oxidize it furthermore. So you can see we are doing oxidation to get nitrogen dioxide. After obtaining our nitrogen dioxide, members, then we are going to dissolve nitrogen dioxide in the water. So our nitrogen dioxide, so we dissolve it in the water which is warm. So we have our water which is hot, and in presence of oxygen, the water must be aerated. Then here we are going to obtain our nitric acid which we want. The nitric acid which we want. Make sure the equation is balanced properly. So you can balance the equation by putting a 4 there. And when you put a 4 there, you will see that hydrogens are going to become not balanced. So we have to balance the hydrogens also by putting a 2 there. But you can look at even nitrogens are not balanced. So we can put a 4 here to balance the nitrogen dioxide. And then the rest we see it is totally balanced. So from there now, we can see now the uses of nitric acid. Uses for nitric acid. Nitric acid is important in the following ways. It is used for making explosives, making fertilizers, you know that one, in agriculture, fertilizers, and many other uses. We have many there. Then let us move at the preparation of sulfuric acid. So members, when you are preparing sulfuric acid, we begin with our raw material. Our raw material will be sulfur plus oxygen then we are going to obtain what we call sulfur dioxide gas. That equation is already balanced. Then after obtaining our sulfur dioxide in the industry, then we are going to oxidize it furthermore to form sulfur trioxide gas. This one is done in the presence of a catalyst known as vanadium pentaoxide. Now the conditions of that reaction, conditions of that reaction, layer one, we have to be with the catalyst. That is catalyst, which is vanadium 5 oxide, which we have talked about. Then two, we have to be with high temperature. That one is crucial. Then even high pressure is also crucial. Then from there, after getting our sulfur trioxide, remember that equation is not balanced, so we have to balance it. Balancing it, we can put a 2 here to balance the oxygen, that is 6 oxygen, then we can put a 2 there. Then after obtaining our sulfur trioxide, remember we dissolve the sulfur trioxide in sulfuric acid. There we are going to get what we call an oleum. Get an oleum, it's a liquid, and even here we are using the concentrated sulfuric acid. This one should be concentrated sulfuric acid. Then we obtain our oleum. Then we have to also balance that equation properly. So we balance that equation properly. So when you balance the equation properly, you can discover that hydrogen there are 2, sulfur there are 2, here even this way there are 2, then oxygens there are 7, it is balanced. Then what we do, we dissolve the oleum, in water. We dilute it in simple terms. So when you are diluting it, here we are going to obtain our sulfuric acid, which we want, which is concentrated. Then we can balance by putting a 2 there. After doing that, maybe you can even look at what called the uses of sulfuric acid. When you are looking at the uses of sulfuric acid, the main one you can see that is used in making fertilizers. Then even in the batteries, those batteries used at home, even in the cars, and many other uses.